How does depth perception work in vision? Imagine standing on a busy street, watching cars zoom by. How do you know which ones are closer and which are further away? This skill is called depth perception, and it allows us to see the world in 3 dimensions. It is a fascinating process that combines both physiological and psychological cues to help us understand distances between objects. Let's start with the physiological cues. One key aspect is accommodation. This is how our eyes adjust when focusing on objects at different distances. The lens in our changes shape to ensure we see clearly, whether something is near or far. Next, we have convergence. When both eyes focus on the same object, they turn inward. The angle created by this inward movement gives our brain clues about how far away that object is. Another important cue is binocular parallax. This occurs because our eyes are spaced apart. Each eye sees a slightly different image. When the brain combines these images, it creates a sense of depth. This is why having 2 eyes is so helpful for depth perception. Monocular movement parallax is another interesting cue. When we move, closer objects seem to move faster than those further away. This relative motion helps us gauge depth as we navigate through our environment. Now let's talk about psychological cues. These cues can be perceived with just one eye. For example, the size of an image on our retina can indicate distance. A larger image usually means the object is closer. Linear perspective is another psychological cue. When we look down a long road, parallel lines appear to converge in the distance. This visual trick helps our brain understand depth. Texture gradient also plays a role. When we look at a surface, textures seem more detailed when they are close and less detailed when they are further away. Overlapping objects provide another clue. If one object overlaps another, we perceive the overlapping object as closer. Aerial perspective is interesting too. Distant objects often appear lighter and less detailed because of the atmosphere. Shades and shadows give us additional information about the shape and depth of objects. They help create a 3-dimensional feel in our visual experience. Understanding depth perception is not just a fun fact, it has practical applications. In fields like ophthalmology, it helps diagnose vision disorders. It is also essential in technology, such as virtual reality, where depth cues create immersive experiences. In the context of systems of protection and defense, depth perception is vital for spatial awareness. It helps us navigate our surroundings safely, avoiding obstacles and accurately assessing distances. This ability is important in everyday life and in professions that requiring precise spatial judgment.